etc. It's all okay. Look down. There is one called Easy QoS. Simple quality of service. That is, do some network optimization of the network. Speed limit. Congestion avoidance. These corresponding functions can also support. Look down. Assurance. It is different from the monitoring and troubleshooting we just mentioned. Troubleshooting is generating errors and telling you why. Then give you the solution. Prevention means you haven't had a problem yet, but due to the powerful database matching in the background, then it thinks you might have a problem now. Give you an early warning. Let me give you an example. You keep your head down playing with your phone. The face is very close to the phone. Then you are probably nearsighted. If you have been close to your phone for a long time, then this controller will tell you. If you go on like this, you will be nearsighted. For example, how hot is the fan now? How much has the CPU reached? How much memory? The possible consequences of going out now. That's what I mean. It hasn't happened yet, but I told you first. This is what a powerful database can do now. What I said above are not the core skills of SDN. The core skills are the first two. Let me tell you again. The first two are actually aimed at the current changes to the networking architecture of the campus network. Because now it is tube well structure. Now in the entire data center. Using a two-tier architecture. Backbone separation. Then SD access is actually aimed at the two-tier architecture. Not a traditional three-tier network. The three-tier is what I call the three-tier architecture. So, it is not a technology used in corporate networks. Secondly, for SD-WAN, it is more for some debugging of export devices. Devices that can be connected to the external WAN at the egress. Implement some intelligent traffic load. Real-time switchover for some failures. Diagnosis, etc. It can do better support. For both SD-WAN and SD access. There are a lot of small knowledge points in it. No instructions given here. Specific to IE we'll talk about. The premise is that you have to learn every function in it first, in order to know what functions it is composed of. All basic technologies for non-enterprise networks. In fact, it was not mentioned in the NA stage. So everyone can't understand this thing at this stage. In the NA stage, everyone should first understand the entire SDN. Where can it ultimately be regulated accordingly? Let's just look at the page. This is called Big Data Analysis. All these controls inside. We can all debug in the form of a web page. That is, for future configuration devices. You configure less. Now each device is configured. There are two ways of external interface and command line. Overall, in the future, SDN will be more debugging based on web pages. You can go to change and view the device parameters, including delivery time, control access, set password, certification, etc. These can all be done on the device. The following is the analysis architecture of some campus networks. These slowly everyone learns the structure to know. Here are some of its insight assurance capabilities. In fact, the functions of many projects can be done now. Okay. We are finally entering the part that you may be most looking forward to. It is equivalent to making a simple summary of the current stage. I will talk about this experiment next. Let's do a review of the previous course content. Then configure the experiment by the way. I'll turn on the device first. Let's analyze the topic first. In this topic are some configurations we learned throughout the NA phase. Basically all have been checked. Although there are not many equipment. But there are a lot of things to check. Let's take a look. First of all, There are 5 routers in the whole picture. 2 PCs. A switch. We're going to configure it. PC1 writes 192.168.1.x here. Then it will not manually configure the address. Let it fetch automatically. We configure PC2 manually. A 2.0 network segment is configured. They are not in the same network segment. Secondly, we configure subinterfaces here on the gateway. We do one-arm routing. Everyone should be able to see. Now the 2 devices cross the network segment. Since this is the case, it is to let everyone do one-arm routing. Connected to the router. We up subinterface here. This is the configuration we talked about before. We want to be on the gateway device. Also enable DHCP. Since this we have manually configured. It does not need to issue IP. Let it issue a fixed IP address to PC1 forever. Is 192.168.1.11. Issue a fixed IP for a fixed MAC. This is what we said before. Then on this device, do network address port translation PAT. Use this outgoing interface to do. Devices inside the future want to go online. This is the NAT we just talked about. We use this way of network address port translation. Point the traffic out. Further down, we want to run OSPF on the R1, R2, R3, R4 device. R1 and R2 each enable a loopback port. 1.1, 2.2, 32-bit mask. Notice 1.1 as a circle. This address can telnet this 2.2. But can't ping 2.2. We just demonstrated the ACL. In fact, it is just a ban on ping. But how can we achieve telnet but not ping? Let's wait for the demo. Look down. In the future, this 1.1 will go to this 2.2. Traffic to be sent. I hope that when the traffic passes, it goes down. When the traffic comes back, it goes up. Actually, these 2 are equivalent. We need to modify its path. That is, need to modify its orientation. I want the traffic to always come like this. The last one. We can only use one static route. In fact, when we do targeted ACL, for a variety of scenarios, sometimes people mess with static. So we have to stipulate. If only one static. We should write this statically here. Write a default route to the public network. So other places. We won't do too many operations anymore. Then we will start the formal configuration. We start the configuration from the switch. We must first enter the configuration mode. Let's rename the switch. Then assign VLAN to it. VLAN 10. Then VLAN 20. After the VLAN is divided, we're going to configure them accordingly. Let's do a simple plan. This is VLAN 10 on the left. On the right is VLAN 20. So we enter the corresponding interface. Interface E01. Switch port mode access. Switch port access VLAN 10. Then we enter the E02 interface of the switch. That is 02 interface belonging to PC2. Switch port mode access. Then assign VLAN to it. Switch port access VLAN 20. Okay. It's not working now. Certainly. The PC has not configured the address yet. We first configure the switch. Go to the interface where the switch is connected to the gateway. This is the 00 interface. Interface 00. After coming in, before we enter switch port mode trunk, have to enter another command first. I mentioned it in class before. It may not be possible to directly enter the trunk, because we have to modify its encapsulation mode first. Change it to .1q. Then, switch port mode trunk. It entered smoothly. Next, we are going to release the corresponding traffic. Switch port trunk allowed VLAN. We're going to pass 10 and 20. After releasing the traffic, we can look at the configuration. Do show run interface. Let's take a look at the configuration under the 00 interface. We first changed its encapsulation mode here. Because the default is ISL, Cisco proprietary, we're going to make it public. But I also told everyone. For many devices in the real network now, many Cisco devices are now .1Q by default. For some devices, you don't need to enter. But some old devices have to enter this command. Then go to modify the trunk mode. Allow VLAN 10 and 20. Change the mode to trunk. OK. I'm done with the configuration of the switch. Let's go to the gateway to configure it next. Other equipment comes first. To save time in class, I have finished configuring the interconnection interfaces of R1, R2, R3, and R4. I won't configure the address in class for a while. You can configure it yourself after class. Let's change the name. It is Gateway. So now I'm going to configure one-arm routing. Gateway configuration one-arm routing. The first step should be no shutdown. First you have to open this interface. Otherwise, there is no way to configure it with a single arm. After the interface is opened, let's go to the subinterface. Interface Ethernet 00. We enter VLAN 10s. This .10 is not its processing capacity for VLAN 10 is identified here.